So Imagine IT Solutions is an Autodesk Silver Partner. We are based in Namibia. We are a 100% Namibian IT company. And we offer services such as digital transformation in architecture, engineering and construction, information technology consulting and management, so your general IT support, hardware sales and software sales, cyber security and software development. We're established in 2014 and we've been in the market since then. So Imagine IT Solutions is a silver partner with Autodesk. And Autodesk is a global leader in design and make technology with expertise across architecture, engineering, construction, design, manufacturing, and entertainment, keeping up with the latest 3D modeling in virtual reality. So Autodesk is popularly known by AutoCAD. I think a lot of the times when we talk about Autodesk, some of the people may not necessarily know Autodesk, but if you say AutoCAD, then they can easily identify the tool. So Autodesk became popular after launching AutoCAD. We know that every architectural and engineering construction project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea into life. Hence why Autodesk Software Tools is the preferred vendor to shape the world and shape the future. So Autodesk developed tools such as AutoCAD, Revit, Civil 3D, and much more, offering digital transformation by integrated technologies into all aspects of business operations. So Imagine IT is also a technology partner with various other vendors. We also offer software from Microsoft, Vim, ESET, HP, Molex, Dell, and so forth. And we can be reached on the following contact details. That is our contact number and email, and our website, which is www.imagineitsol.com. So I'm just gonna stop here and hand over to Elijah so that he can take us through today's session.
Can you see my screen?
Yes, we can.
Okay. Okay, so thank you once again, everyone, for joining us in this webinar. So I'll quickly start my presentation. Just a moment, I hide this. Okay, yes. So we are going to discuss some very interesting things here, especially when it comes to how you are able to elevate your design processes and project delivery, where we are going to look at various workflows, especially for design of your maybe roads, buildings, trying to capture all the aspects of the projects, like maybe whether it's architectural, structural, MEP, electrical, civil. And I'll maybe just first go through the presentation through to the end, and maybe at the end of it, we'll have a Q&A session. So maybe if there is any question that you might have, you can either post it on the chat or on the Q&A tab, or just hold on with it until the end, that we maybe can unmute you, then you just put it across. So this basically is the agenda. We aim at finishing by 11:30. And the key focus will be largely around infrastructure, but I will also look at some aspects of also vertical buildings. There's the normal architectural, structural, and MEP design for our buildings. So as myself, Elijah Ochieng, I work with Walsey as the BM specialist and applications engineer for infrastructure. More than 7 years practice in the civil engineering space. So as shown here, we just want to maybe first have a discussion on possibly some of the challenges that you guys are probably having in your project delivery, and then look at some of the current ways of doing things, the new trends, and how the industry is overall responding to the challenges that we are facing. Then after that, we look at the actual solution or the process that I'm proposing, which would ideally help you to transit and elevate how you are currently delivering on your projects. So in terms of industry challenges, which I believe one of the key challenges that we face as construction professionals is what we call the working in silos, where from the traditional approach to project delivery, or generally how most of the projects are contracted, we know that there may be silos for architects, engineers, fabricators, contractors, that it is by nature or by design that each of us are meant to work separately. But that in itself brings a lot of problems, especially in terms of the project delivery. That it basically means there will be no proper coordination and collaboration, issue management, and sometimes there's even maybe so that the aspect of constructability doesn't usually come in very well, where that each team works independently or separately. And then once the design is completed is when you now try to merge them into one at the end by maybe submitting some construction document that are sent to the contractor to work with. So it brings us a lot of challenges, especially in terms of maybe document continuity, project handoffs, and also in the actual contract management also becomes very, very difficult. I'm not really saying that we need to completely move away from that's basically the design and build project or method of project delivery. We are still able to work with that contract method, but there are better ways that can enable or enhance collaboration and coordination, which basically is going to ensure that we are able to manage and solve most of the project, if not all, issues of the project that are usually coming as a result of how we currently work. Things like maybe managing change requests, revisions, and the related aspects of the project. Also, there's the aspect of also distributed team. So the fact that this design and build most of the time teams are distributed, that unless you are a multidiscipline company, of which even if you're a multidiscipline company, most of the time you get a project, but you still want to work with some other external consultants who may be located or seated within the same country with you, could be maybe in different countries, or maybe a client could be in different location or part of the country, then consultants and contractors who coming in from different regions. So that in itself also brings in a lot of issues in terms of the team being distributed. So how can we ensure that we manage our project, especially from a communication aspect, sharing of data, sharing of information, before we even go to the aspect of collaboration and coordination that requires even better tools to help you manage the project properly. So with that, there are various trends that ideally I've always, every single time I get a chance to present or talk to people, I like putting across that if you are working within the AEC space or the larger construction industry, whether an engineer, an architect, you are maybe an owner or operator, you are a contractor, is the high time that you must be very, very familiar with these new trends that are really taking up the industry. Most important of them is the building information modeling, and that's where my presentation will be centered around. There's the aspect of digital collaboration, artificial intelligence, very, very important, is strongly coming out, especially within the last 1 year. Cloud computing, digital twin, smart cities, BM and GS integration, very, very important one, and sustainability. So these are some of the areas that as an engineer, as an architect, as a contractor, construction manager, ideally you should understand how are these going to impact my work? And how am I able to integrate them within what I'm currently doing to basically enhance, especially on efficiency and effectiveness of how I'm delivering on my projects? Like, for example, if it's about artificial intelligence, doesn't really mean that you have to maybe go into the details of it and then maybe go learn, register for a course. But you just need to understand, how can I be able to incorporate it? Like if I'm managing projects, you're basically using predictive analytics to be able to help you know how your project is going to perform, maybe in terms of budget, in terms of time, overall issue management, overall contract delivery, and very many other aspects. Yeah. So understanding and knowing how to incorporate aspects of these technologies within your project is very, very important. Some of them are actually a must, like sustainability. Almost every client we work for, design for, are looking for sustainable design. They are looking at you delivering a digital copy of the as-built model. And you are not able to do that if you're not using some of these tools, especially building information modeling. And for example, you can't talk about cloud computing, digital twin, smart cities within construction projects if you're not using building information modeling, for example. So like GIS and PM integration is very, very important. This basically what helps you to understand the existing environment or the context on which the design will be done and construction will be done, so that you're able to make an informed decision in terms of maybe how to design, build, and operate while making reference to the existing project context. The aspect of digital twin, very, very important. So I've already mentioned that some customers or some clients or some cities and municipalities are already looking at the consultant construction team. Part of their deliverables should be a digital model. So people no longer look at the normal deliverables like the 2D PDFs and the rest, but they want you to go to the extent of providing digital copies of the as-built, which can later on be used for operation and maintenance. Then the cloud computing, very, very important. You basically have to, you probably are using it without even knowing that, for example, if you are sharing your information over the internet, maybe like communicating via mails and all that, but only that in this case, you're looking at using it for storage, retrieving, sharing, analyzing, simulating, and other related aspects of project delivery beyond the conventional way of just cloud as a software service, but you can also use it as a platform and also as an infrastructure. Then smart city, I believe almost at least every African country right now are talking about, or not every, but majority of them are having maybe a particular smart city. They're not really doing it the way it's intended, but some conversation are already developing a smart city somewhere or something related. Maybe they call it technopolis or technocities with various naming and terminologies being used. And again, this is where you as a consultant or a designer, you also need to be ahead of the game, that you'll be able to know and understand how best this kind of cities can be done, can be delivered, and exactly what's needed to be incorporated, especially from a design point of view. And lastly is the use of drones, which is very, very important, especially if you're in the infrastructure design, how you are able to incorporate it for efficiency, especially in data collection, reusability of the data, and even data informing the future of the operation and maintenance of the same is very, very critical from that aspect. So especially talk about BM, would be a silly aspect in terms of now policies and processes, tools and technology, data standards, and even people and skills. It's very, very important from a BM point of view, because for BM, we basically look at integrating the entire project life cycle. That the same information I'll start off with from the project inception ideally should influence the decision that's going to be made even on how to operate a particular built asset. So that's why there's the aspect of that technology and tools, the aspect of people and skills, the policies and the processes, like if policies, how are we going to execute the project? What specific processes are we going to use? And when you move from maybe the plan, how are we moving to the preliminary and detailed design? How will we do the exact handover? But if it is people and skills, we look at maybe like the request for proposals, the bids and the preview, the review, still execution planning, construction, and even acceptance of the project. Yeah. Then there'll be the aspect of operational maintenance, which looks at now the facility conditions and the system's performance and monitoring, maintenance activities, and emergency response activities and mitigations for the project as well. Yeah. So BIM now we look at the overall project life cycle and how to integrate and ensure that every specific phase relates with the other and are able to efficiently manage and deliver the project in its entire life cycle. Several people who have used BIM have reported quite a number of benefits, especially in terms of costs, in terms of improving on schedule, reduction of errors, optimizing the design, and also bettering the understanding of the project with the statistics as shown. And actually, this is as far as 2014, when this was done by the Construction Global Markets in 2014 to be able to just tell us. Right now, I'm very sure some of these statistics have again increased, but I just want to put it as that in as much as 1 decade ago, people are already using this kind of technologies or processes to deliver on their projects, while in us, we are still very, very far behind. And therefore, that's why there's need for us to change and see if we can catch up with the rest of the world. So for example, if you talk about an infrastructure point of view, we are basically looking at the overall project life cycles, as I've mentioned, in terms of how do we do our planning, conceptualizing it, preliminary design, detailed design. How do we move from the design phase to the construction phase? There's the aspect of constructability checks, aspect of coordination, aspect of simulation. Then after that is when you do the actual construction. And once we've constructed it, how do we hand over the digital copies or as-built models that will be used to help the owner operate and maintain the built asset? So basically what that brings us is in the summary that BIM basically is the foundation of digital transformation. That for us within the construction industry to say that we are transforming, just like in other sectors of the economy, ideally we need to find how best we can incorporate and include BIM within our project deliveries. It will basically empower collaboration, decision-making, and better project outcomes for all project stakeholders, and also in connecting data that will allow for continuous iteration and improvement. And as I said, it applies to every specific phase of the project. The main aim is to integrate and ensure that the entire project life cycle is connected. And that doesn't mean that you have to change the contractual methods, as I was saying. We can still maintain the conventional ways of our contracts, for example, if it is design and build, but ensuring that we just digitize and make the circle connected in a manner that you're able to make references to any phase. But those who have implemented find that it works very well, especially if we were to do design build, as opposed to design bid and build. So design bid and build is the conventional one that most projects, actually, I think more than 90% of the projects follows the design bid build. But if you were to now move slowly and incorporate design build, it has its own challenges also, but the overall process still remains the same, as you are able to see that from this. The main aim is to end up with a digital copy or a digital twin of the built asset that can be used for operation and maintenance. So as Martha mentioned at the beginning, Autodesk being the leader, the technology leader within the construction industry, they basically produce applications and tools that are really championing and developing the advancement of BIM, of this digital transformation that we are talking about. And some of these tools and technology that I'm going to discuss here, we are very much familiar with them, like probably you might have heard of AutoCAD, or you might have used AutoCAD without knowing that the owner of the developer is Autodesk. So what I will do in this case, I'll just show, as I mentioned, a workflow or a seamless process that you can use to implement projects that will ensure that we are taking it to the next level when it comes to the project delivery. So not only does Autodesk produce their own products, but they also develop applications that can allow for integration with some third-party applications. Like, for example, we know that when running a particular project, there is need for you to have by the side a particular ERP system, which might not be necessarily Autodesk. So like maybe it's a SAP or other related ERPs that help you to manage other aspects of the project, like maybe the HR, the people and the rest. You can be able to integrate with the Autodesk application so that the project is managed wholesomely, as opposed to having different systems that maybe don't communicate with each other. So the way Autodesk applications are made to work with projects is more or less in a similar way, like someone who is born today, you need to maybe start crawling, walking, running, and then later on being decommissioned. It's the same way this Autodesk application works, that if I'm starting a particular project today, I will need to maybe collect data, update it, design, connect, and then distribute. And it keeps on developing one by one until you are able to have a full project. So basically means that Autodesk has applications for almost every single phase of the project. And some of them actually overlap. That I start the project today to do concept or to do feasibility study. But as I keep on developing it and adding more data, the same application will be used while communicating with others within the maybe a particular package that enables for that data-rich set of information that can later on even guide in overall operational maintenance and even decommissioning of a particular built asset. So that's what we're basically trying to say, that maybe you can be the aspect of rolling, walking, running, and even flying with the information that you got. So as I mentioned, at this level, what I can maybe quickly do is to give a quick overview of how we would use this application in a workflow process that can enhance or elevate a project delivery, especially from an infrastructure point of view or from a vertical building point of view. So the main aim is basically to look at how do we connect the data. That's the most important thing, while focusing on the overall project timeline, project milestone, and looking forward to better project delivery while using these Autodesk solutions. And the two product solutions that I'll be using is the AEC collection and the Autodesk Construction Cloud. That as we go along, I'll be able to explain what each of them are and what are the specific solutions that are in it that will enable us to deliver this project that I'm going to talk about. So like the Autodesk Construction Cloud is basically a cloud-based solutions that are for more like I say, project management, but incorporating communication, coordination, and collaboration. Like if I want to develop a plan, how do I manage project aspects when planning, like in terms of design authoring, design collaboration? If I'm in the actual design phase, how will I manage coordination, clash detection while incorporating both 4D and 5D, quantification, and even bid management? There's the aspect of building now when I'm down the actual project execution. There's types of project management, cost management, quality, safety, and even project closeout. And lastly, even in the operation phase. And while doing this, we know that there's the aspect of things like the RFIs, costs, specifications, drawings, photos, and videos that you use to manage the project. And as I said, that these applications even has the aspects of AI. The Autodesk Construction Cloud has what we call the Construction IQ, which is basically an example of an AI-enabled application that it's able to help you predict and even know exactly how your project is likely to perform. And we all know that AI basically uses information and history and data. So based on the history of your project, Construction IQ in the Autodesk Construction Cloud is able to tell you as the project manager or project admin that based on how we have been performing the last 3 months, this is how it's expecting you to perform. If you don't put any necessary measures different from what you already had in place in the last 3 months. So maybe if it's telling me that based on how we had performed the last 3 months, my project is likely to maybe take this long. So that basically helps the project manager to be able to know exactly what to put in place to be able to bring back their project on track. Just as an example. So the Construction Cloud has several modules, like there's the BIM Collaborate, there's the Takeoff, there's the Build, and many others. But the key applications are these 3, all running on the background of the Autodesk Docs, which is for managing documents. So like for example, docs, if I want to be able to do things like document control, permissioning, approval workflows, design reviews, and overall communication within the project management part, we are able to incorporate and integrate them within one single platform that basically will ensure that all team members have access to the information they need anytime, anywhere within the project. So I'll take a basic project life cycle that we know that mostly we need to do planning, designing, building, and operating. So ideally, I need to understand what happens within the planning phase, what happens within the design phase, what will we do at the building phase, and even the operation phase. So as I say that you are trying to elevate how we do the project. So what I'll do, I'll take a simple road project and take it through each of those project milestones within a particular period of time. And then we'll see how we are able to deliver it. So for example, I can subdivide our project milestones further. So like within the planning phase, what happens for a typical infrastructure project would be the purpose and the need analysis that I need to understand. Why do we need this road? And for what purpose? Then after that, I need to understand also what are the various alternatives that I can be able to consider for this particular project. That's the planning phase. Once I'm done with the planning phase, I will go to the design phase. So it basically means that we have provided justification for why we need to do a particular project. And justification basically could be economic justification, technical, social, and those very many other aspects that you need to consider at the feasibility study. Then once you've justified that there is need to have a road, then what are the alternatives that we are having? Can I dual it? Can I maybe do a bypass? Or can I maintain the status quo? Like remember that do zero or do nothing is also an alternative sometimes. Then after that, we can go and now start gathering information in form of existing conditions and data collection, GIS, and surveying. Then we develop the design. We do model condition under the design phase. After that, we'll go after finishing the design, there will be the aspect of constructability review, clash detection, or basically the pre-construction activities. Then we'll proceed into the actual building, that's the field execution. Once they have exited the field, we will do the project closeout, then deliver the assets to the owner. So that's basically what we will do. So in terms of our purpose and need studies, we have a solution within the AEC collection called InfraWorks. Very, very good application for feasibility studies, concept, and preliminary design. So like in this case, we are using it to perform traffic analysis and simulation, basically to help us understand that there is a need of improving the road. Heavy traffic exists. Okay, apologies. There would be some background noise. I think someone has just tried to maintain the office in the next building. So I'll apologize if you guys are hearing any noise wherever I am. It's beyond my control. So I'll just retake that so that I explain it once again. So we'll say that in this case, we are doing purpose and need analysis. So one of the primary purpose of doing a road is to help elevate traffic congestion. So with the use of Autodesk InfraWorks, you're able to gather traffic data and analyze and simulate. It's able to tell you the current delays, the current time it takes individuals to move from point A to point B. So that once you have indeed seen that there is heavy traffic congestion, then we are able to use that to justify that we need to either do all this road or basically increase the number of lanes to accommodate the many vehicles, or we can introduce an alternative route or a bypass so that people who are just going through should use the bypass while the local traffic should maintain their existing routes. Then there'll be the aspect of using Autodesk docs to share and communicate this information that I could be the client seated at location A who needs to review and give comments to what the engineers have done, the engineers that are sitting at location B. So how this information is communicated is very, very important. That traditionally what would happen, there would be call for a design review meeting or maybe presentations and several back and forth communications. But the way this is going to help you manage this aspect is that there is how you are able to remotely share and communicate on the project. That at my desktop, wherever I am, I'm able to publish and share the design that I'm proposing. And you as the client or the owner, wherever you are seated, or the project manager who needs to review this, will be able to remotely get access to the information and give me real-time feedback and information on what you think. If you think that the current alternatives that I'm evaluating are okay or not, and maybe if you have a suggestion on how best you'd want it done, as opposed to what I'm proposing. So by the time I'm coming or we are calling for a meeting, we have already discussed a lot, so that it's just coming to confirm one or two things that ideally might have not been coming out correctly when we do it remotely. So once we've done purpose analysis and need assessment, and we have settled on a particular alternative, we would proceed to now start gathering data. And again, the most important part is how this data is going to be gathered, shared, and integrated within the project, because data gathering, data collection is where most time is wasted, and also most resources also goes in here. Several surveying is done, several acquisition of just data is done, but the way we are currently using that information in the project is in silos, that the surveyor doesn't care as long as they have collected the data. How they are going to publish and share that information and whether it's going to be used in the right way don't usually come out correctly. So there's a process that you can still maintain the conventional process. That's the use of conventional surveying methods like GPSs and auto stations. That is still acceptable. But most important is the building of it, like the aspect of having the georeferenced model, aspects of having imageries that communicates a lot more information than just the point data collected, so that I'm able to see my project location in real time or in the context of where the data was collected. So traditionally what you'll be seeing is just the points without having that imagery in the background to help us know exactly the route, the existing buildings, existing road, the existing land use that exist within the project location. So that conventional will still be accepted. And this is traditionally some of the strong areas of Autodesk Civil 3D that has always been there over the years. Okay, but if you want to learn that, there's the aspect of linking it up with the various imageries, either from satellite or from various GIS sources, so that it's able to make it more context to what you're doing. Beyond that, there is the aspect of what we now call the reality capture. This is a little bit more advanced. This is why I can either propose use of drones, propose of using LiDAR or laser scanners. So this now enhances accuracy, and actually is what's recommended if you have to go to this level of design. There's an enhanced accuracy, reusability of data, better understanding of the project, because you can see they are all in 3D, so that even if you are not technical, you're able to easily relate and make better understanding of what's being done, as opposed to the one you have seen in the previous slide, which was a little bit more technical. Okay. So again, once again, I'm still apologizing. Our next office door, they have decided to do some renovation. We didn't get a memo. So if you hear a lot of noise in the background, kindly bear with me. So this is now InfraWorks and what we call Recap Pro, the primary applications you use to process and prepare survey data. So it means that the surveyor collects the data on the ground from the site. They share with the engineer, and I'll be able to show you how that sharing is done in a more coordinated and collaborated way through the Autodesk docs. So the key part here is in terms of reusability of that information, understanding of that information, and also being able to quickly develop design concept out of that information compared to the one that you have seen in the previous slide, which I've said that, yes, it gets the work done, but usually there are a lot of loopholes. The chances of misunderstanding or misconceiving a particular information is very, very high. So if you are to use a drone, very, very simple. And again, I think this is the one which I ideally have preferred most in that it easily gets the job done. If you're using conventional surveying, the surveyor will take several hours, months, weeks on site. But a drone, if it's let's say a 60-kilometer road, the survey can be done within like in less than an hour. And this will get you a real-time data that you can still prepare using almost conventional process that you're used to, like things like defining ground control points or benchmarks, and linking those ground control points and benchmarks with the model will still be done. And recap make it so easier that you as the engineer or the surveyor just chooses exactly what process you'd want to follow and what will be the exact data output that you'd want to have. So this is a context, real context site information that can be reused anytime, anywhere within the project delivery phase. So then also the other aspect of gathering GIS, this is very, very critical also, and one aspect that most of our projects fail in, especially in establishing existing conditions, underground utilities, overhead cables, existing land use. This information you can easily get from GIS data. And the best person to get this information from would be the local authorities or local municipalities who operate and own things like stormwater, sewer, water distribution networks, and other related aspects of the project. Okay. So this is the sharing part where we use the Autodesk Build to share. So the Autodesk BIM Collaborate Pro and Autodesk Docs to share. It basically allows you to define work sets and packages and who you'd want to consume and use them. And then after that, you're able to keep track of the various aspects of that information and how it's going to flow from one point to the next. There's the aspect of accountability, because I'll be able to know when a particular work set was consumed, when was it used, and then was it again reshared for a particular person within the project. So in terms of developing the topography, the overall design aspect of the information, all of them will be managed within one interface, so that the engineer will just need to log into the platform so that they're able to make reference to the surveyor's work while doing their actual design. So once the data is gathered, the next thing is now to proceed to the design. So we have done purpose and need assessment for the project. We have established alternatives that we have picked one. We have done surveying. We have acquired GIS data to show us what is existing below the ground where the project is. Now we are ready to start doing the design. So the design, again, we are not now going to start anywhere, because traditionally what would have happened, sometimes at this phase, we still need to go and gather more data, but the kind of data that you have gathered and how it was stored enables us to retrieve it for ease of making reference to it when doing the design. So my work as the designer now is just to lay out my geometry on plan and maybe on profile, on the cross sections, and quickly we'll start running quantitative analysis to enable me define the cost of the project. So like the sectional views of the design. And this basically where Civil 2D comes out to be very, very strong application when it comes to the geometric design of the road. But you can take it further by using what we call the computational design through that's the Autodesk Dynamo, which is very good at basically using kind of linear programming, or basically what's called computational design. If there are aspects of like bridges, all of them will be incorporated into one. Like I have structural bridge, whether it is the steel girder or concrete deck girders, you are able to quickly choose and develop the geometrical details of the bridge, run analysis, because Autodesk Infrastructure itself has the aspect of structural bridge design, that it links up with the Autodesk structural bridge design to help the designers come up with the accurate and precise structural details that will follow specific code-based design standard. Then how this is shared is very critical again. So the bridge, you can basically be able to store, reference, and utilize the sheets from which the details of the bridge has been prepared. Then that will still enable the overall communication, coordination, and collaboration, which is surely very, very critical aspect of project delivery for structures as well as the geometry that you are working on. So we are now done with the design. So the next part is basically to look at what we call the model conditioning, and then we'll quickly run constructability checks. Those are things like clash detection and overall coordination. Then after that, we'll just deliver on our project. But the aspect of pre-construction will also involve quantities, preparing schedules, and maybe programs of work that we will now issue for the contractor to follow to deliver the project. Okay. So that's what I will drive at quickly through the model conditioning. So basically what model conditioning is talking about is just basically preparing and verifying. Like if I want to take off my model, I want to quantify it. What are the unit rates? What are the various quantitative measurements that I'm going to take? Is it maybe for the earthworks, for the bases, for the sub-base, for the subgrade? And exactly what are the precise quantities that I'm looking at? Are they in line with what we had done based on what exists on the actual ground? So basically, this enables me to check and verify that whatever I'm designing and quantifying ideally conforms to various material investigations and other geotechnical investigations that were done on site. So that if I'm saying I'm going to have this much earthwork, is it also convey the same thing that we want to see on site? If I'm saying I'm going to have this kind of guardrails, is that something that can easily be implemented? And what are the various specifications of the types of maybe guardrail, the material requirements, and quantitative measures that ideally we must have with respect to that. So Autodesk Docs, again, is still being used to manage and track all those kind of activities. So that once I've input them in the model, whoever is receiving and reviewing my work, it's just a matter of dropping down and checking what are the material specifications that the engineer had given, and are they in line with what you are expecting from maybe the scope of work that the engineer was assigned to do with respect to this project. So once you've done the model conditioning, that everything is confirmed, so the next thing before you move to the site to construct is to run constructability check and clash detection. So this is actually a very critical part. Traditionally, what we do with we call this design review. It's actually a phase on its own. But doing it is not really very easy, especially if you're working from 2D. So this application, this is Autodesk BIM Collaborate Pro. It has the aspect of clash detection. So first, you need to aggregate all the design model. Like you see, this case, I'm having drainage, traffic, electrical, structure, pavement. So I'm just quickly running each of them, and it will be able to clash detect that is there an aspect that is likely to clash with each other, that if the contractor was to implement it as it is, will he be having issues in delivering the various aspects of it? So it will tell us the possible areas of clashes, so that what I will do as the project manager or project director at this stage is to ensure that each team members coordinate and agree on constructability. So like this case, there's an example there of an electrical part that's a street light clashing with a drainage structure. So the agreement is between drainage and the electrical guy. The electrical guy has agreed to reposition his element. And once all the issues are resolved, we can quickly go through Navisworks to help us construct it virtually. And as it constructed virtually, it comes out with a construction sequence or program of work that usually we do in MS Project or in MS Excel. So this is a little bit more automated in that. From the models, I just need to specify what is the project start date, what's the project end date, what are the various resources that you're having, and how much piece of work can we do a day. And therefore, based on that, from the models, how best can we construct and sequence it to ensure efficiency in the timeline for the project. So Autodesk Navisworks is very, very good at doing that. And the output of the file is something you can share with your MS project, basically for further verification and check. Especially if you're already having an existing template from MS project, you're able to even import it and get started from it as a background of your project schedule. So now that we have quantified, we have scheduled, basically we have also costed, you are able now to start doing your field execution, basically the actual project delivery. So where whatever will show at this stage for project delivery is largely with respect to managing activities, like managing requests for information, working with managing issues, schedule, progress tracking, meeting minutes, submittals, forms. So basically the specific activities that you work with on site to manage a project. In this case, I'm just highlighting an example where the contractor on site is finding that there's an existing culvert that the design did not capture. So it's raising an RFI to the client and the consultant to give direction and whether they should demolish that existing culvert, whether they need to verify or do condition survey and check if it can be reused within the new project. So how they are communicating, that's very, very important. Traditionally, this would have required several back and forth with several site visits. But in this case, contractor being on ground just takes photographs and videos, upload and share it when creating the RFI to the designer. So what the designers need to do is just to go into their design models and check. Like in this case, they're redesigning and verifying if it will impact quantities at that specific location. Remember, that would be a variation. If not managed, it can even result in 20% cost increase. So proper communication and proper management of that issue and tracking it to closure is basically where the value of this process comes in that we are trying to avoid a potential variation by managing it very early and having precise way of managing the actual issue. So like if it's a redesign, the client is already in the picture, so they know what to expect. But the consultant, the contractor can be able to manage just to ensure that it doesn't blow out to something else that really was not planned for. So all those aspects in terms of progress tracking, you can see they are listed here. So that's I've just highlighted the example of RFI. There'll be the aspect of the submittals, managing the site meetings, progress tracking, schedule, asset and report, and all that can be managed. So I'll again assume we have done the construction now, so we just need to close out the project. So project closeout, usually basically looking at preparing as builds. That's the most important part. So there's the aspect of as built preparation, of which is not so much difficult. Remember, we have been making changes within the models and the designs as we were proceeding. So the client and the contractor won't have to spend several hours, days, months preparing as built. You just need to confirm what was built versus what you still have in your design model. So like in this case, there's a flared guardrail that initially the designer had done it as straight. So the contract is just updating and saying that it was initially straight, but now we did flared ones. And then it's just a matter of packaging and sharing it. And plus all the photos, all the progress details that were prepared will be shared directly. And it's just not of publishing, not even sharing, because they're already available within the project management platform. That's the Autodesk build that you just publish and share with the owner through the verification and approval of the consultant. Then lastly is the asset delivery. So asset delivery is assuming the operation part. Again, I'll take a typical example of what happens during operation, like where the owner need to maybe replace a particular bridge component. So what the first thing is they must have the models that were delivered. That's the digital assets. Like in this case, they were delivered through Autodesk InfraWorks. They are basically the same environment where the design was done, is the same environment which will be used also for operation. But though for operation, there'll be the aspect of integrating it back with GIS. If you remember when I talk about GIS, we used it to inform us on design. And once you have designed, remember whatever is designed and constructed forms part of the environment again. So it means that we'll need to publish whatever that was designed and built into GIS again. So once it has been published, it means that in terms of real-time tracking, so this is where the aspect of maybe using a SCADA or sensor to communicate. So some sensors could be installed on bridge component because no bridge is a very sensitive infrastructure. So we can have a sensor that is monitoring vibration, movement, and deformation on the bridge, so that if there's excessive vibration, maybe there's a particular heavy rainfall that had come, we need to know how has it interfered with the bridge abutment, the bridge piers, the overall road component, so that if we were to plan for operation and maintenance, we'll be planning it based on real-time data on what's exactly happening on the ground that is linked up with the built asset, the digital copy of the built asset. So like these are mentioning the bridge bearing. So information about the bearing, information about the abutment, all were contained and submitted to the client that they are able to monitor and track. And if you need to maintain or replace a particular part, they check real-time information from the built soft copy that was shared. So that's basically how we are able to work with this BIM process for infrastructure. There would be very many more, but of course, as we said, we can't be able to deliver all those within one sit down like this. But I strongly believe that was highlighting and showing how we are able to use that. And the most important application that I've mentioned several is the Autodesk Docs. And it's basically what is streamlining this in terms of communication, because what will make your project to fail or succeed is just communication. So that's why Autodesk Docs comes out very, very strongly in that it will help you to do transmittals, to do design review, connect design and construction, issue management and issue tracking, approvals, and very many more. So that's where most of the conversation I was actually centering around, to show that communication is the biggest aspect of project delivery. Then there was also the aspect of coordination and collaboration, clash detection, and overall project management activities, as you have just seen within the process. So that basically was largely around infrastructure. So I'll take maybe the next few minutes, not more than 10, to highlight the vertical buildings also. So like maybe architecture, structure, MEP, and even the constructions of the same. So again, I'll just take more or less a similar approach, but I want to go into the much details as I'd gone with the infrastructure. So again, with the assumption that probably we have those who are not within the civil space, but either architecture, structure, MEP, so at least that all of us who attended feel all taken care of and at least can walk away with something from this session. So the key aspect of this still remains that in terms of design automation, in terms of predictive analytics, in terms of the reality capture, generative design, overall project lifecycle analysis, quantity takeoff and estimating, all of them are still, you're still able to take care of from the same package or solutions that I've been talking about from the beginning. So for infrastructure, the key application, if you remember, remained largely InfraWorks. But for building now, it's like going to be largely Revit, which I'm very sure most of us maybe are either familiar with or could possibly be hearing of it for the first time. So, but Revit itself doesn't work alone, just like in infrastructure. InfraWorks was working with Civil 3D, was working with Navisworks, was working with the Recap and the rest. So like in this case, Revit will be working with first Formit. Formit will be the application we'll be using to perform concept design, to basically understand our site, to help us perform energy analysis, to basically to enable us establish the design. Like if I want to do my project for a building, I need to first understand where exactly is this project going to be located, so that I'll be able to know the existing roads there, existing building, so that I can be able to properly plan to know how whatever I'm going to propose is likely to coexist with what already exists. Okay, so like this case, maybe it could be in an urban center or a built-up area, but there's a small open space that we need to do a building. So like creating masses is very, very easy with Autodesk Formit. So you can do parametric sketching. So, and these parametric sketches are also going to define the actual building, because I'll be able to move this concept mass into a schematic design that will take into Revit that will inform the detailed design. But the most important part of it is the aspect of analysis in terms of energy studies, things like sun path analysis, solar studies, and various planning or land use activities, like whether it's going to be residential, commercial, and all those aspects of the design. So once you finish the design in Formit here in Forma here, that's what you'll take into your Revit. or sometimes you can still go through the Autodesk format to perform some various adjustments and analysis. And you can see in terms of the site design, like the parking areas, the parking layouts, all those can still also be incorporated for the proposed project that you are developing at that stage. Once done, there will be the aspect of also where you can perform it through maybe your mobile device. Sometimes you don't have to sit directly on your tablet or your desktop. Like both Forma and Formit are all online applications, but they're the aspect where you can install the desktop applications of them. So that if I so wish, I can just maybe grab my tablet or my mobile device and then start the design anywhere where I am. So again, we know that as being architects, being creative designers, that a particular creative idea can come to you when you're even on the move. So you don't have to wait until you get to the office, sit down on your desktop or on your computer, is when you start doing the design. So in this case, even if I'm on my mobile device or if I'm on my tablet, I'm going to grab it wherever I am and then start just laying out the sketches, just being creative the normal way that they do to be able to develop the concept. So once that concept is developed, then you just take it to Revit, from which you'll be able to advance the design further and produce the various details as may be necessary. Okay, so like this case, you're just playing around with it. We want how many floors do you want? What's going to be our facade materials? Like maybe the glazing that you're going to have. So you just need to choose from the list of the material library there. Then you can even do sun path analysis, basically to see the impact of the shadows that the existing building there will cast on your proposed building, because you know that will define energy utilization. If your building is always on the shadow of the existing buildings, it means that the rooms are going to be dark, and therefore you need to continuously light it during the day. Then after that, you can do heat map analysis, basically to see the impact of the sun, like if sun is from one direction. Then after that, you can go to perform overall simulation of it in terms of building orientation. But of course, this follows a benchmark or a design standard. Like in this case, you can use ASHRAE or the AIA 2030 commitment or the normal green buildings studies and design guidelines. Once completed, you send it to Revit, where you need to complete the design by producing elevation, floors, sections, and various design as might be dictated by the project that you are doing. Then after that, the next will be the structural bit of it. So very important part in terms of the structure. That the aspect will be to perform structural modeling, structural analysis and code design, library-based design, and if it is still the aspect of steel connection. So this will still be Revit, but now with a robot for structural analysis. So it means that 2023, once the modeling is done, steel connection design. So what I want to show is the modeling part. Modeling is actually very, very easy. It won't spend much time. But the biggest part will be how do we load our structure? How do we come up with things like bending moments, shear forces? Then how do we now proceed to the design, like connection design, structural member checks, and verification? So Revit comes with inbuilt library. That's just a matter of the engineer checking and verifying that if I were to do this kind of connection configuration, how will it perform with respect to the loads that are applied on my structure? Okay. Then there's the aspect of also structural analytical automation, that from the physical model, how do I move it into the analytical model? That's basically the idealized structure. Basically, it's showing me the interaction of the member, the load transfer, and the support conditions that I might have to opt for. So this again is automated. Though if you had used Revit before, this might be a bit of a challenge, because before it was when I'm modeling my physical model, analytical model was preparing itself in the background. But with the new change, I think this since 2023 model, it was revised that once I've done the physical, then I choose to automatically produce the analytical model on it, following various standards and computational design requirement that defines the relationship between wall, column, beam, and how they are going to interact to form the supports and connections that will ensure efficient load transfer from the topmost part of the structure to the lowest part of it as well. So once you've done those settings, just a matter of clicking run. And once I've clicked run, my analytical model will be prepared. So analytical model is the model that will be applying the loads, the model that will be analyzing, and it is the model that will be sending to robot for specific detailed structural analysis. Then once I've analyzed it and got my bending, shear forces, axial loads, and the rest, I will bring it back into Revit so that I can complete the design. So again, the workflow is very, very seamless, but of course you need to understand how the process works so that you're able to get it correctly for correctness of the design output. And again, one thing I need to mention that robot, for example, as application, does not have that aspect of garbage in, garbage out. So before you move from Revit to robot, your model must be 100% accurate, because structure is now very sensitive for a structural engineer, that any single mistake you make, your building will come down. So robot does not accept that aspect of garbage in, garbage out. You have to ensure you verify robustness, materials, properties, and all various specifications, and load takedown structure so that everything is correct before robot is able to analyze and give you the output. So then lastly, if you are having maybe concrete structure in terms of concrete design and concrete detailing, bar bending schedule, shop drawings, quantities, and all those will all be taken care of again within your design. So structural detailing made easier. Traditionally, if you are to do this, you would be doing it in AutoCAD, where we know that there are a lot of changes. You can't track changes. You can't easily do changes. Like every single change that is made, you'll have to manually do it in the entire project. But like in this case, if it's Revit robot, I just make change on the 3D view, and then the corresponding elevations, sections, and other details that have been produced will automatically reflect and update as per the change that I've done. So basically meaning that we know that there's no single structure you can just do it on once. There will be variations and updates that are pending based on maybe the meetings with the client and all that. So Revit makes that very, very easier for you. You are able to track the changes with the Autodesk BIM Collaborate Pro, and you're also able to easily communicate and have overall design variations and changes made easily within the overall project delivery team. Okay. So then lastly will be that aspect of project sharing, which you have already said that is through BIM Collaborate Pro and Autodesk Docs. There will be the aspect of collaboration, coordination, and communication that basically ensures that things like design review, consumed packages shared, and overall change visualizations will easily be made within the overall multidisciplinary team that is working on the project. So that multidisciplinary basically means that there is the aspect of maybe mechanical, electrical, and the architecture that you have mentioned in the previous part. And then the coordination is if the multidisciplinary team basically means the aspect of clash detection, and therefore you need to visualize, mark, and track all those changes. And this at the long run ensures that you are reducing the cost of the project. Okay. So then there'll be the aspect of detailing, which I think I've already mentioned, and then also the clash-free. So once you've run clash detection, you'll be having a clash-free model, which can easily be constructed, and that ensures that there is no rework on site. The project can easily be delivered quickly. Then lastly, we'll now be just quick to show something on mechanical as well. So still using Revit, mechanical or building service team are also able to do the optimized building design while using leading simulation engines. They're also able to monitor performance and changes over the project. And this is using Revit and an engine we call Autodesk Insight, which is used for building studies for basically to ensure that if I'm going to do heating and cooling for my building, it should be based on a study and a statistics. If I'm going to do my day lighting for the building or overall operational energy requirement for the building, it should be based on a study, especially climate and weather for the specific location of the project. But again, this will be guided by various benchmarks and studies. either as per the ASHRAI, as I've mentioned, or as per the AIA 2030 commitment, which are all guiding principles and standards for sustainability and high-performing building design. Okay, so that's what this is highlighting, that really, so you should look at the model history, the benchmark. The aim is by the time you're done with the design, it should be green. It should give you a green here. So you start off from somewhere, then make adjustment in terms of the method of heating the building, method of cooling the building, the lighting, how the architect has done the wall to window ratio for natural ventilation. Okay, then in its aspect of heating and cooling loads, all of those will be incorporated so that every specific change and variation that I make should aim at lowering the energy consumption or energy use of that particular building that I'm having in question. So that once I've done all those parameters, it will produce a report that will guide me now on how should I now go and size and do my things like HVAC. That's basically the heating, ventilation, and other ducts that you might have within the project. So this basically ensures that you have that full detail or complete incorporation of all aspects of the building into one, so that we're able to check and verify based on design guidelines and design principles that is giving us correct output. Then the next part will just basically to again produce your quantities, fabrication components to ensure accuracy in terms of the output of the design that we are highlighting. Okay. So then there'll be an aspect of to do constructability checks as well for your MEP component, because there will be several components that are incorporated, and therefore to avoid clashes, the MEP or service team can as well still run clash detection, just to ensure that we are able to have an error-free or a model that will not result into any rework once we deploy the contractor on site.
Autodesk Revit enables
So this is what I was
detailers
calling
to create coordinated
fabrication models. So in terms of cutting, knowing the shapes, the sizes of what to produce, so that we minimize wastage on site, is very, very important aspect of the project as well. So I think that's basically what I'd prepared to show. I don't want to show anything further, maybe so I can allow for some questions and answer. So that aspect of a building part, I said I would not show it in details, but the process remains exactly the same with what I'd shown on the infrastructure part. So maybe what I'll do, I'll just allow for